Because an adaptive rider is either sitting or prone on their bike, they're looking at the trail from a much lower perspective than your average two-wheeled rider. Plan for this with good sight lines from lower perspective. An adaptive rider will have the most fun if there are no surprises. A trail can still be technical and feature-rich, but the rider should be able to see where they're getting into before they begin their descent with sufficient time to react as they navigate the trail. Blind drops, sharp corners after rollers, and large obstacles after sharp turns can cause accidents if a rider can't see them in advance.
Flow is essential to a good mountain bike trail. It's important to keep corners open and long and to avoid bottlenecks. That way, adaptive bikes can maintain proper speed the whole time. It's also really important to provide pullover areas so that riders can pass each other and so that we avoid traffic jams.
Trails are often purposely cambered downslope to allow water to flow off the trail surface. Adaptive mountain bike optimized trails might use other ways of managing water runoff, as the tread might be more level or insloped rather than outsloped. Keeping the trail as perpendicular as possible to the force of the bike minimizes shear forces. Water management on adaptive descending trails may take extra consideration. More infrastructure might be required for directing and dispersing water more often. Even a minimally outsloped trail and a sweeping turn can pull an adaptive bike off the trail. Lengthening the tail of a swoop and adding a culvert can manage riders and water.
When it comes to fall consequences, it's all about exposure. Tipping over is a hazard of adaptive mountain bike riding, but not all tip overs are created equal. If an adaptive mountain bike rider tips over at a level grassy field, they likely won't get hurt. If they tip over down a steep embankment, it could result in injury, as well as great difficulty returning back to the trail.
Obstacles in the trail tread are often a good thing, but the camber and exposure of the trail need to be taken into consideration. If an obstacle lifts a rider's wheel that is already on the high side of the camber, it could lead to a high consequence crash. Remove or lower obstacles that create tipping hazards and leave those that don't.
The most obvious consideration when it comes to bridges is just the width of the bridge, right? The adaptive bikes can range, but they can get all the way up to 40 inches sometimes. So the first consideration is just to accommodate the actual width of the bike. And then after that, you need to start to think about all the details, like how high off the ground is that bridge? Does it need curbing or a railing? And also speed can become a major factor. So another consideration, what the entry into that bridge is. Is the trail headed directly into that bridge, or is there a little bit of an angle? Because all of those things can drastically change the flow that's going to happen and the speed that an adaptive bike is going to be able to carry across that bridge.
Adaptive bikes can handle steep terrain. The biggest limitation is erosion control. If a trail has to follow the fall line, then it should be rock armored to prevent erosion, and it should only follow the fall line for short periods of time.
When we're building berms on a downhill trail and we're considering an adaptive bike, one of the main things that we're looking to do is make sure that the end of the corner especially is almost opening up and continuing to be insloped and captivating that rider for a longer time. The risk of having a shorter tail to a corner or an oxbow at the end of a corner is that it's so difficult for an adaptive bike, which has so much momentum and force and weight that's pressed into that bank, to shut their speed down in order to not kind of like blow out of the end of that corner and then get their speed back. It's kind of like a flow destroyer. When it comes to the turning radius of a downhill corner, a little consideration needs to go not just to the actual trail tread itself, but to the surrounding terrains. When you're building a bench trail, making sure that that back slope is smooth, so that is not just chunder and roots and rocks. That's a place where there's a little more leeway for that bike to move around. And even on the downslope, like having that be solid and not just a bunch of duff or unstable material, just giving a little extra room for the bike to find the best line that suits the type of bike you're on and the rider themselves. Anytime you're building jumps, you're taking into consideration the speed of the rider and how everything flows together, right? The approach to that jump needs to feel consistent and needs to feel predictable. You can't be unsettling the bike before you hit a jump lip. You can't have something so blind that you don't have any idea of where you're going. It takes some expertise to build jumps that are not just fun, but also predictable and relatively safe.
Always have an adaptive rider vet a trail. Sightlines are very different when a rider is seated in an adaptive mountain bike versus perched high on the saddle of a two-wheel bike.
Progression is one of the most important things you can do when building adaptive mountain bike trails. You really want a trail network that everyone has a chance to get better on. Most of the times you probably think these hard lines won't go, but they probably will. Thank you so much for watching this series, and thank you so much to Vermont and this community for making all this work. There's nothing better than seeing an entire parking lot full for a trail system that we built that builds community. And that's what's most important. I hope to see more of these networks out there. So if you have any questions, please call. We'd love to talk about it.